pembuangan sisa plastik dari Sungai Kelang antara penyumbangan utama.
Ini terlalu bahaya untuk digunakan akibat pencemaran.
Salah satu puncanya adalah sampah.
Assalamualaikum and hello to Dr. Nur Hidayah. My name is Fatina Bila and today I will be talking about one of Malaysia's most significant environmental challenges, which is water pollution in Sungai Kelang and why we need urgently a holistic integrated solution to address it. Sungai Kelang is a major river flowing through Selangor and into the Straits of Malacca. It stretches over 120 kilometers and passes through multiple local councils, making it a lifeline for both urban and rural communities. Despite ongoing rehabilitation efforts, the river continues to face serious environmental pressures. Let's look at some recent real-world pollution incidents. The first one is severe organic and chemical contamination. In April 2025, Sungai Teluk Gong, a tributary of Sungai Kelang, was found to be so polluted that aquatic life could no longer survive. Tests revealed high levels of ammonia, biochemical oxygen demand, and chemical oxygen demand, indicating toxic organic pollution, likely from industrial and sewage waste. The second one is colored and chemical effluent from industries. In July 2025, parts of Sungai Kapal Kecil turned colored due to illegal discharge by a plastic recycling factory and a latex storage facility. Authorities confirmed that wastewater had flowed directly into the river system due to inadequate containment measures at these industrial sites. Addressing Sungai Kelang's pollution cannot be done by cleaning up debris alone. Here's why. The first one is multiple sources of pollution. Pollution comes from industrial discharge, domestic waste, and urban runoff all at once. A single solution focused on only one source will not solve the whole problem. We need a coordinated strategy that includes regulation monitoring, enforcement, and community participation. The second one is cross-agency and cross-district coordination. Since Sungai Kelang flows through several local councils, cooperation is essential. An integrated river basin management plan would align all stakeholders to work toward the same goals, reducing fragmentation and policy gaps. And the last one is sustained community engagement. Local residents, schools, businesses, and NGOs must be part of the long-term solution, supporting education, river cleanups, reporting violations, and monitoring progress.
The pollution of Sungai Kelang is mainly caused by a physical, chemical, and biological factor. Firstly, physical pollution such as plastic and construction debris enter the rivers due to poor waste management and surface runoff. This causes blockages and reduce water flow. Secondly is chemical pollution. It comes from industrial effluents and domestic wastewater. This release harmful substances like heavy metal, detergents, and nutrients which increase BOD and COD levels and reduce oxygen in the water. Thirdly is biological pollution. It occurs when untreated sewage introduces harmful bacteria such as E. coli, leading to eutrophication and the death of aquatic life. These causes lead to serious environmental impact, including loss of biodiversity and ecosystem damage. Socially, nearby communities face unpleasant odors and reduced quality of life. Economically, pollution increases water treatment costs and causes flooding due to clogged waterways. In terms of health, exposure to polluted water can cause waterborne disease, skin infection, and long-term health risks due to the toxic contaminants.
We will now present the third part of our assignment, the proposed integrated solution for water pollution. Water pollution is a complex engineering challenge involving multiple sources, pollutants, and stakeholders. Because of this, a single solution is not enough, so our proposal integrates engineering treatment and smart monitoring for sustainable long-term impact. First, for the engineering solution, we propose upgrading wastewater treatment plant using membrane bioreactor (MBR) and advanced oxidation process (AOPS). These technologies can effectively remove organic matter, excess nutrients, heavy metals, and hazardous compounds, while meeting DOE Malaysia effluent discharge standards. Despite higher initial costs, they provide high efficiency and lower environmental risk. Next, we integrate AI and smart monitoring system by installing real-time river sensor to track parameters like pH, dissolved oxygen, turbidity, and ammonia. AI will analyze the data to predict pollution events and send early warnings, enabling faster response and better decision making. This support SDG 11, sustainable and resilient cities. Through this integrated approach, we ensure that solution is not only effective but also sustainable and resilient for the future.
Next will be policy and regulatory measures. The second dimension of the integrated solution is policy and regulatory control, which ensures that engineering solutions are properly enforced. Stricter enforcement of the Environmental Quality Act of 1974 is required, especially for industries operating near rivers. This includes higher fine for illicit discharge, compulsory environment audits, and more frequent inspections by authorities. Such regulatory measures help prevent negligence, encourage compliance, ensures that industries take responsibility for their environmental impact. In addition, economic instruments can be used to support sustainable practices. Industries that adopt advanced wastewater treatment technologies or water recycling systems can be given tax incentive or subsidies, while polluters may be charged through pollution taxes. This approach promotes responsible consumption and production, which directly supports SDG 12. Public participation is also important. By providing public access to pollution monitoring data and conducting awareness campaigns, communities become more informed and involved. This strengthens ethical awareness, transparency, and shared responsibilities among citizens. The third dimension is natural treatment using ecosystem-based approaches. We propose the use of constructed wetlands and riparian buffer zones along polluted riverbanks. This system relies on natural processes involving plants, microorganisms, and soil to remove nutrients, suspended solids, and certain toxic substances before they enter the river. This solution is cost-effective, requires minimal energy, and provides additional benefits such as biodiversity conservation, erosion control, and flood mitigation. It also enhances climate resilience and supports long-term environmental sustainability to the environment and make our environment more cleaner. In conclusion, the proposed solutions are more effective when implemented together. Engineering solutions provide technical efficiency, policy measures ensure legal compliance and ethical responsibility, and natural treatment systems maintain ecological balance. When combined with AI technology that famous nowadays, the overall system becomes more adaptive, efficient, and resilient. Overall, this integrated approach is effective, feasible, cost-efficient in the long term, legally compliant, and environmentally sustainable. It strongly supports SDG 11, which is sustainable cities and communities, and SDG 12, which is responsible consumptions and productions, while addressing complex water pollution challenges in Malaysia.
In this part, we evaluate the proposed solution for Sungai Klang water pollution based on how effective they are, how easy they are to apply, their cost, their sustainability, and whether they follow legal and safety requirements. The engineering solution uses a smart wastewater treatment system with AI monitoring. This solution is very effective for Sungai Klang because the river receives pollution from many factories and residential areas. Advanced treatment systems such as membrane bioreactors can remove most organic pollutants like BOD, COD, and ammonia. AI sensors can monitor water quality in real time and quickly detect illegal and abnormal discharges. However, this system is expensive to build and needs skilled workers to operate, and this makes it less easy to apply everywhere. Even so, in the long term, it can reduce pollution, protect public health, and lower river cleaning costs. This solution also follows Malaysia's industrial effluent regulations. The policy and regulatory solution focuses on stronger law enforcement under the Environmental Quality Act 1974. This solution is easy to apply and low in cost because it depends on rules, monitoring, and penalties rather than new technology. For Sungai Klang, where pollution often happens due to poor enforcement, this solution is very important. Its success depends on strict and consistent enforcement. If the rules are properly followed, this solution can prevent illegal discharge and encourage industries to manage their waste responsibly. Lastly, the natural treatment solution uses constructed wetlands and buffer zones along the river. This solution is environmentally friendly and sustainable. It helps cleaning the water naturally and improve the river ecosystem. It is also low cost and uses very little energy. However, the solution needs enough land, which can be difficult in highly developed areas along Sungai Klang. Therefore, it would best when combined with engineering treatment system. In conclusion, for Sungai Klang, using engineering solutions, strong laws, and natural treatment together is the best way to reduce water pollution in a sustainable and long-term manner.
In conclusion, the health of Sungai Klang is a reflection of our collective responsibility. The incident we have seen in 2025, from the chemical districts in Sungai Teluk Gong to the plastic waste at the river mouth, serve as a wake-up call. We cannot treat the river as a backyard drain and expect it to function as a frontline resource. Transforming Sungai Klang from a Class 3 river to a vibrant Class 1 ecosystem requires more than just high technology filters. It requires integrated governance, strict industrial accountability, and a shift in how we can, as a community, value our water. If we act like now through a unified, holistic approach, we can turn this historical waterway into a symbol of a urban resilience rather than a casualty of industrial growth. Let's protect our Sungai Klang, not just for today, but for the generation who will inherit it tomorrow. Thank you.